10 Chinese megacities are running infrastructure that New York City will not have for another 100 years. That is not an opinion. That is what happens when you compare a city still using traffic signals designed in the 1970s to a city where artificial intelligence controls 12,000 intersections at the same time. That is what happens when you put the New York subway, which moves about 1 billion riders per year, next to Beijing's, which moves closer to 3.5 billion. That is what happens when you put JFK Airport next to a terminal built in under 5 years that processes passengers through facial recognition from the front door to the boarding gate with half the staff. New York is iconic, but iconic and advanced are two very different things. These 10 cities are not just bigger. They are smarter, faster, and more connected in ways that are genuinely hard to believe. Until we look at the hard data, we are going to go through how far behind the West actually is, starting with the very philosophy of how a city is built. The core of the structural gap we see today lies in the layers of history that define our Western urban landscapes. In the United States, and specifically in New York, we are constantly engaged in a struggle of legacy. We are trying to patch, repair, and update systems that were laid down a century ago. It is like trying to install the latest high-end software on a computer from the 1990s. Eventually, the hardware just cannot support the demands of the modern era. In stark contrast, many of these Chinese urban centers had the opportunity to leapfrog entire generations of technology. They built from the ground up during a period of unprecedented technological explosion. They did not just build roads, they built smart roads embedded with sensors. They did not just build a power grid, they built a self-healing, AI-driven energy network that operates with a level of efficiency we are only beginning to theorize about in our engineering labs. To truly understand this, we must look at the city of Tianjin. Most Americans have never heard of this location, yet it is currently running one of the most sophisticated urban experiments on the planet. The Sino-Singapore Tianjin Eco-City is a full district where every single building is connected to a smart power grid that balances energy from solar panels, wind turbines, and the main supply every single second of the day. When one building generates more solar power than it needs, the grid automatically sends that extra energy to a neighboring building. No human decision is required, and there is zero administrative delay. The system treats an entire neighborhood like one shared battery. This results in carbon emissions that are roughly 60% lower than a conventional development of the same size. To put that in perspective for us, imagine if the entire Upper West Side of Manhattan shared power like a single, intelligent house. That level of digital and physical integration simply does not exist in our current urban framework. While we are still debating how to fix a single subway signal or renovate a decades-old terminal, these cities are operating on a digital backbone where transit, energy, and identity are woven into a single, seamless fabric. We are looking at a future where the city itself thinks and optimizes its own resources in real time, leaving the old models of urban management far behind in the rearview mirror. As we move from the general philosophy of urban design to the specific engines of economic power, we begin to see where the real competitive edge lies. We are talking about the physical and digital infrastructure of production. In the United States, we often view a factory or a port as a standalone entity, a place where people go to work and machines perform specific tasks. However, in cities like Suzhou and Tianjin, the very definition of a facility has shifted. These cities have transitioned from being collections of individual businesses to becoming massive, integrated nervous systems that respond to global market demands in real time. This level of coordination is something that our current industrial parks in the Midwest or our shipping hubs in California simply are not equipped to handle yet. Take a close look at the Suzhou Industrial Park. This is not your typical manufacturing zone. It is one of the most advanced industrial ecosystems on the planet because the factories within this park do not operate in isolation. They are connected to each other through sophisticated artificial intelligence systems that share production data every millisecond, For us to visualize this, imagine a network of hundreds of separate factories behaving like one giant, coordinated assembly line. If one facility experiences a shortage of raw materials, the AI system immediately detects the deficit and instructs another facility in the network to adjust its output to compensate. If a sudden surge in global demand for a specific product occurs overnight, the entire network shifts its resources before a human manager even has time to call a morning briefing. This is a level of manufacturing intelligence that we are still only testing in small-scale pilot programs in the West. In Suzhou, this is the standard operating procedure. It removes the friction of human error and the lag time of traditional logistics, creating a production environment that is faster, more precise, and incredibly resilient to external shocks. Beyond the factory floor, the precision of these cities extends to the sky. The Suzhou Zhongnan Center is a prime example of how engineering and data merge. It features a super tall tower equipped with a tuned mass damper system that maintains stability during heavy winds. This is not a passive weight. It is an active system that detects building movement and executes corrections hundreds of times per second. Even the elevators are intelligent, moving 48 people at a time in double-deck cars, managed by a central AI that learns the movement patterns of the people inside. It adjusts the climate control, air handling, and water management before the occupants even realize a change is needed. This is a building that essentially anticipates the needs of its inhabitants, operating with a level of foresight that makes our iconic skyscrapers feel like relics of a simpler time. Then, we must look at the way these cities handle global trade. Tianjin is not just a city. It is home to one of the world's most advanced automated ports. Every year, it handles tens of millions of shipping containers, but it does so without a single human driver on the ground. Automated cranes and guided vehicles move cargo with a level of precision that manual operations cannot match. Ships arrive, unload, and depart on schedules calculated by machine learning systems that can predict potential weather or logistical delays long before they occur. Contrast this with the Port of New York and New Jersey, which remains one of our busiest hubs but still relies heavily on manual labor and traditional scheduling. This reliance makes the entire process slower, more expensive, and far less predictable. What we are witnessing is the birth of the thinking city. It is a place where every component, from the energy grid to the factory floor to the shipping port, is part of a single, unified data stream. This connectivity allows these cities to run with carbon emissions that are significantly lower and production rates that are significantly higher than anything we see in our own major metropolitan areas. For the mature observer, the question is no longer about who has the biggest buildings. The question is about who has the most efficient system. While we in the United States continue to focus on individual innovations, these megacities are focusing on total system integration. They are proving that when you connect every part of a city's industrial and energy heart, you create a powerhouse that can outpace the rest of the world without breaking a sweat. It is a silent genius at work, and the results are becoming impossible for us to ignore. When we look at the sheer scale of urban mobility, the difference between a city that is merely large and a city that is truly advanced becomes undeniable. In the United States, we often pride ourselves on the legacy of the New York City subway, a massive system that moves roughly 1 billion riders every year. But when we place those numbers next to a city like Beijing, which moves closer to 3.5 billion people annually across a network of over 400 stations, the scale of the challenge and the achievement changes completely. It is not just about the length of the tracks or the number of trains. It is about the intelligence that coordinates every single movement within that massive web of steel and data. While our systems struggle with aging signals and frequent delays, these megacities are operating on a digital backbone that feels decades ahead of anything we currently experience in Manhattan or Chicago. The most striking example of this intelligence is found in Hangzhou, a city that has implemented a system literally called the city brain. This is not a metaphor. It is a centralized artificial intelligence that pulls data from over 5,000 cameras, millions of connected devices, and every single transit vehicle in the city simultaneously. For us to understand the power of this system, imagine an AI that does not just watch the traffic but actually runs the city in real time. In Hangzhou, if an accident occurs, the city brain detects it instantly. Within seconds, it reroutes traffic across hundreds of intersections, dispatches emergency services, and adjusts the timing of every traffic light along the affected corridor to ensure smooth flow. In its first year alone, this system reduced urban congestion by 15%. In a city of 10 million people, that 15% translates to millions of hours returned to the lives of its citizens every year. One of the most impressive features for us to consider is the green wave provided to emergency vehicles. In New York, an ambulance has to fight through gridlock just as it did 50 years ago, relying on sirens and the hope that drivers can pull over. In Hangzhou, the city brain calculates the exact path of the ambulance in real time and turns every single traffic light green as the vehicle approaches. The path is cleared before the ambulance even arrives. This is the difference between a city that reacts to problems and a city that prevents them. Furthermore, the entire network is so integrated that if a metro line experiences a delay, the bus routes throughout the city adjust their schedules and paths automatically to absorb the extra demand. The city functions as one single, living organism rather than a collection of separate, barely cooperating departments. Then there is the matter of how we pay for and access these services. In the United States, we are still having debates about the reliability of contactless credit cards for transit. In cities like Shenzhen and Beijing, cash and physical cards have almost entirely disappeared from the daily experience. Around 95% of transactions happen through mobile systems or facial recognition. Whether you are entering a subway turnstile, buying street food, or paying for a parking meter, you simply look at a camera. Your face is matched to your account, and the transaction is completed before you can even blink. This level of connectivity extends to your identity and building access as well. Your phone or your face is your metro pass, your credit card, and your office key all rolled into one seamless digital identity. This leads us to a broader realization about the nature of modern infrastructure. Beijing's traffic management system controls over 12,000 intersections at once, pulling data from millions of sensors every second. When you drive through a city like that, you are not following a fixed timer set by an engineer decades ago. You are moving through a network that is watching you and adjusting to your presence in real time. This level of synchronization has cut average commute times by 30%. It makes us wonder, as we continue to invest billions into repairing our aging 20th century systems, are we simply fixing the past while the rest of the world builds the future? Is it enough for our infrastructure to be iconic? Or has the time come for it to be truly intelligent? We have to ask ourselves, as we see these advancements in real-time traffic coordination and seamless digital integration, how much of our daily frustration in the West is simply a result of outdated thinking? If you could have a commute that was 30% faster and never had to wait for a red light again, what would you do with those extra hours every week? Do you think the convenience of a cashless, facial recognition society outweighs the privacy concerns we often discuss here in the States? We would love to hear your thoughts on whether you think our Western cities should prioritize this kind of total AI integration, or if there is a middle ground we are missing. Please share your perspective in the comments below. In the world of urban development, the most expensive mistakes are the ones we realize only after the concrete has dried. In our major American cities, we often build a new highway or a residential complex and then spend the next 20 years trying to fix the traffic congestion or the utility shortages that it caused. This is a build and fix mentality. But in Chengdu, they have pioneered a completely different approach. They build a digital twin of the city first. A digital twin is a high-fidelity virtual copy of the entire metropolitan area, every road, every bridge, every underground utility pipe, and every transit route updated with live data. Before a single shovel touches the ground for a new project, urban planners test it inside this digital simulation. They can project how a new residential tower will affect water pressure or how a new subway station will shift the flow of millions of people 3 years into the future. They find the problems and solve them in the virtual world, ensuring that when the physical construction begins, the result is already optimized for the next several decades. This level of foresight is how Chengdu Tianfu International Airport was constructed in roughly 4 years, designed from day one to handle 80 million passengers annually. While New York's JFK Airport is currently entangled in a multi-decade renovation plan that has seen repeated delays and budget shifts, Chengdu built a smarter, fully integrated airport in less time than it often takes us to approve a single planning document. This airport isn't just a place for planes. It is a sensor-rich environment where AI crowd management tools predict where bottlenecks will form before the crowds even gather. The facility adjusts itself, opening new gates or rerouting passenger flows before the travelers even notice a potential delay. It is a proactive relationship between the city and its residents that makes our current infrastructure feel reactive and slow. If Chengdu is about the digital perfection of the future, Chongqing is about the physical impossibility of the present. Known as the vertical maze, Chongqing is a megacity built across mountains, valleys, and cliffs with elevation changes of over 3,000 feet. For most Western urban planners, this terrain would be a nightmare that prevents large-scale development. Chongqing, however, looked at these extreme conditions and built a city of over 30 million people anyway. Because there is no flat ground, the infrastructure has to be three-dimensional. The city's metro system doesn't just go underground. It burrows through mountains and rises onto bridges hundreds of feet above the Yangtze River. In one of the most famous examples of this vertical integration, the metro line actually passes directly through the 6th floor of a residential apartment building. The train enters the building, stops at a platform inside, and exits out the other side while residents continue their daily lives in the apartments above and below. Chongqing has over 13,000 bridges, more than any other city on Earth, because in this landscape, a bridge is as essential as a traffic light. The Kayuamba Bridge, for example, is a massive structure spanning 6,500 feet that carries cars, trains, and pedestrians simultaneously on separate levels. But these bridges are not just concrete and steel. They are embedded with thousands of sensors that feed continuous data to maintenance systems. These systems can predict exactly when and where a repair will be needed based on the stress, temperature, and vibration patterns of the structure. In New York, our aging bridges and tunnels are inspected on fixed cycles, meaning a problem could develop and worsen in the months between inspections. In Chongqing, the bridges essentially inspect themselves 24 hours a day. The city also boasts the world's highest outdoor escalator system, climbing over 400 feet up a cliff face to connect different neighborhoods. In this environment, vertical movement is just as common as horizontal movement. We see a level of engineering ambition here that challenges our basic assumptions about where a city can exist and how it should function. The city also features the Crystal, a horizontal skyscraper that is over 900 feet long, resting on top of 4 other towers. It contains restaurants, shopping, and an infinity pool, essentially creating a second city street hundreds of feet in the air. This brings us to a critical realization. The cities of the future are not limited by their geography. They are limited only by the technology they choose to deploy. While we in the West often treat the landscape as an obstacle to be avoided, these cities treat it as a canvas for innovation. They are proving that with the right combination of digital simulation and vertical engineering, a city can thrive in even the most challenging environments on the planet. We are looking at a level of urban resilience and creativity that is setting a new global standard for what a megacity can actually be. When you can build a train that runs through a kitchen and a bridge that monitors its own health, the traditional boundaries of architecture and engineering simply disappear. When we reach the final stage of our journey through these urban marvels, we arrive at Shanghai, a city that does not just represent the future, but actively operates within it every single day. In the United States, our fastest rail connections, like the Acela in the Northeast Corridor, still struggle to maintain speeds that would be considered average in many parts of the world. Meanwhile, Shanghai has been operating the maglev for years, a train that covers 19 miles in just 7 minutes, reaching speeds of 268 miles per hour. There is no friction, no rail contact, The train literally floats on magnetic fields. For us to visualize the gap, the New York Air train to JFK crawls at 40 miles per hour and is frequently plagued by delays. Shanghai built a system 6 times faster just to bridge the gap between the airport and the city center. This is not just about speed, it is about a fundamental commitment to moving people with the highest possible efficiency. The intelligence of Shanghai extends far beneath the tracks and into the very heart of global commerce. The Yangshan Deepwater Port is perhaps the most otherworldly place on this list. It is the busiest container port on the planet, handling tens of millions of containers every year, yet it operates almost entirely without human presence on the ground. Automated cranes and robotic-guided vehicles move with a mathematical precision that human operators simply cannot match. When a massive cargo ship arrives, the system calculates the optimal unloading order for every single container and assigns a path through the port instantly. It executes these operations faster, and with a fraction of the workforce required by facilities like the Port of New York. This is what happens when you turn a shipping hub into a fully automated digital ecosystem. Even the skyline itself is intelligent. The Shanghai Tower, rising over 2,000 feet, is a masterpiece of sustainable engineering. Its double-skin outer shell creates a spiraling atrium that acts as an insulation layer for the entire structure. Inside, thousands of sensors monitor wind pressure, temperature, and air quality on every one of its 128 floors. An integrated AI system adjusts the heating, cooling, and ventilation independently for each section, cutting energy consumption by 30% compared to conventional skyscrapers. This is not just a tall building, it is a living, breathing structure that actively manages its own environment to minimize its footprint. It is a level of active engineering that makes our most famous towers feel like static monuments of the past. But perhaps the most profound change for us to consider is how the city has redefined the daily transaction. In Shanghai, the digital and physical worlds have merged into one seamless experience. You can move through your entire day boarding the metro, buying lunch from a street vendor, entering your office building, and paying for parking without ever touching a wallet, a credit card, or even your phone. Facial recognition terminals are everywhere. You simply look at a camera, and the city's digital backbone takes care of the rest. While we in the West are still navigating the complexities of different apps and physical cards, the residents of Shanghai are living in a cashless and keyless reality. The city functions as a single, unified network where your identity is the only key you need to access every service. This total integration is the big picture we must understand. The reason these 10 cities feel so far ahead of New York is not just because they have more money or more people. It is because they were built with the philosophy that everything must be connected. In our Western cities, we have separate systems for transit, for payments, for energy, and for emergency services, often barely communicating with each other. In these Chinese megacities, the transit talks to the payments talk to the identity system, and the roads talk to the AI. The result is a city that behaves like a single, living organism that optimizes itself in real time for the benefit of its citizens. New York remains a world-class icon of culture and history, and there is no doubt about its lasting impact on the world. But when we look at the hard numbers and the daily reality of moving through a city like Shanghai versus moving through Manhattan, the technological gap becomes impossible to ignore. We have to face the reality that while we have been refining the 20th century model of a city, another part of the world has already moved into the 21st. It raises a serious question about our own future. Are we willing to rethink our entire approach to urban living to close this gap? As we close this analysis, we want to hear your perspective on this massive shift in urban technology. After seeing how these 10 cities operate, which advancement do you think would be most beneficial for our own American cities? Is it the AI-controlled traffic, the high-speed maglev trains, or the seamless digital payment systems? Do you believe New York can ever catch up? Or is the legacy of our old infrastructure a hurdle that is simply too high to clear? We invite you to share your thoughts and join the conversation in the comments below.